So in this video, we're going to look and see how we can use the graph of a function to determine um, what the whether the values that aren't part of the domain are asymptotes or wholes. So I've already graphed the function here on Desmos.com, and in the last video we already showed what the domain was, right? The domain was all real numbers except for 0, 1, and 5. So those are the only places, x equals 0, x equals 1, and x equals 5, where there might be an asymptote or a whole. So the first thing, I guess, looking at this, right, we're definitely missing part of the graph, because all the numbers here besides 0 and 1 themselves, right, all the numbers between them anyway, should be part of the graph, and I don't see anything. So what I'm going to do is I'm going to start zooming out until I see something, and then down here I start seeing something. You see, I'm going to zoom out just a little bit more, and we can see this little piece here. So now we can see the vast majority of the function, or at least what we're interested in. And we can all see a bunch of stuff we're not interested in, right? I'm not so much interested in what happens for these x values down here, the -20, the -40, the -60, -80, right? The only ones I'm really interested in are 0, 1, and 5. I'm not really interested in any of these ones either. So I'm gonna switch my my viewing window here, so that way, maybe it goes from -1 up to 6 or something like that for the x values. And I'm going to also look at the y values, right? I am pretty interested in the y values because I want to know if we have asymptotes or not. So maybe I'll even make my y values go a little bit bigger, up to 100 and down to -100, just to get a better idea of whether we have asymptotes or not. Okay, so a couple of things, right? So we know the domain is all real numbers except 0, 1, and 5. And so what I would do if I were you is I would start tracing the function and see what happens as we get closer and closer to 0. And it looks like to me, as we get closer and closer to 0, as the x values, get closer and closer to 0, it looks like the y values are becoming bigger and bigger and bigger, right? That's if I'm approaching from the left. If I'm approaching from the right, and I'm starting to make my x values get closer and closer to 0, it looks like my y values are going to -infinity, right? So this is a pretty good indication here that we have a vertical asymptote at x equals 0. And I'm even going to put that in here. And you can see this vertical asymptote in green here. You can see how it looks like the function is approaching that green line as we get closer and closer and closer. As the x gets closer and closer to 0, it looks like that function's approaching the green line, and the same thing on this side. As x gets closer and closer to 0, it looks like the function's approaching the green line. And something very similar happens at x equals 1. As I start making my x values closer to 1 from the left side, it looks like the y values are going to -infinity. Whereas if I start approaching from the right of 1, it looks like my values of the function are getting closer and closer to +infinity. So that's a good indication that x equals 1 is an asymptote. And if I put that in there, it seems to bear out that the function appears to be approaching this blue line on both sides. So these two both appear to be anyways vertical asymptotes. If you wanted to verify that they were in fact vertical asymptotes and there wasn't something happening up here, up there, down there, pretty crazily, what you'd have to actually do is you'd have to do the algebra just like we did in the last video. So the other thing that I want to now look at is I want to look at what's going on here at this point 5, and I'm going to zoom in a little bit just to show you something. So if you look at this, there doesn't look like there's a hole to me. I don't see a hole anywhere. We know there's a hole because we know it's not part of the domain, and we know it's definitely not an asymptote, so it has to be a hole. And if you trace the function and get closer to 5 and closer to 5 and actually get to 5, whoops, hang on, let me get to 5. There we go. You see how the hole appears there? And then we also have, it says 5, I don't know why I can't get it. 5 and undefined. There we go. There it is. Look at that. There we have the hole there, and we have 5 and undefined. So, but Desmos doesn't actually show you that. And the reason is because there's lots of numbers that are close to 5 that have y values, and it's plotting all those dots too, and all those dots make it look like 5 is covered when it isn't actually. So if you want, what you can do on your graphs for the holes, just to show other people, is you can add the hole in there, so that way Desmos will show you the hole. And in order to do that, you have to do a little bit more algebra. So I'm going to go back to the notes that we had last time. This is from the last video where we saw the same thing, that x equals 5 is a hole, x equals 0 is an asymptote, and x equals 1 is also an asymptote. So what we're going to do here is as follows. We're going to take this function here that we have in red right here. Now, this is not the same exact function as f of x, because, you know, there's no x minus 5 in the bottom and no x minus 5 in the top. But that's okay. So I'm going to call it something different, though. I'm going to call it g of x. And g of x is very, very similar, as I said, to f of x. The only difference is that x equals 5 will now be in the domain of this function, right? Because there's nothing in this function prohibiting 5, right? If you plug 5 in here, it won't be 0. If you plug 5 in here, it won't be 0. If you multiply the two of them together, you won't get 0. So what we can do is we can find what 5 would be if it was part of the domain of f of x by figuring out what g of 5 is. So we're going to do that. Just plug in g of 5. G of 5 is equal to x plus, hang on. We know what x is now, right? G of 5 is equal to 5 plus 5 divided by, in the denominator, 5. Here, maybe I should put parentheses on my x's. Times 5 minus 1. Now, order of operations, I have to simplify the numerator first and the denominator. Those are grouping symbols. So let's see, 5 plus 5 is 10. And in the denominator, let's see, I have 5 times 5 minus 1 is 4, right? So grouping symbols, I'm still multiplying out the denominator, 10 over 20. And 10 divided by 20 is 1/2, right? So whereas f of 5 is undefined, g of 5 is 1/2. Like, if we were to fill in that dot would be 1/2. We can't because it's not part of the domain, but, you know, if we could, that's what we would do. So now that we know that, what we can do here is we can just let everybody know that there's a hole when they're graphing it. We can plot that point, 5, 1/2. And what I would do if I were you see how it became a black dot on my screen? That's not 100% helpful because people can't see there's a hole. But if you click this edit list button, you can edit a whole bunch of stuff. If you click on the black circle over here in the list, you can change the style to make it a hole, and also the color. I changed it to red just because the function's in red, so why not? And now someone else who's looking at this graph would very quickly be able to tell, oh man, there's a hole at 5. 5's not part of the domain. So you can use algebra, and algebra is very, very helpful for determining whether there's a hole or you can use the graph, and that's very helpful for determining whether there's an asymptote. But if you only use the graph and don't use any algebra, you're going to miss some holes. So it's important to have both methods down.